Hello everyone. How are you all? I am Nupur Rana from GEMA Math, and today we have got a really interesting topic, algebra, or I should say basics of algebra. So as you know that the algebra starts from algebraic expressions because these are what forms the algebra. Okay, and these algebraic expressions contain variables, constants, and everything. So we will get to know more about them as we go on with the class. But first of all, what is actually algebra? Does anyone know? Algebra. Yes. So algebra is actually used to find out unknown quantities. It will be used as you go on in mathematics, know more about it. Algebra will be used forever. So these are used to know about the unknown quantities using x's and y's, alphabets, Greek letters, just to know what do you want to find out. So first of all, algebraic expressions, and what are these? Let's find out. An expression that contains at least one variable, constant, and an operation. Yes. So first of all, these are the terms that we will be using all throughout the class. Okay. So first of all is our variable. Second is our constant. Third one is our operation. So let's not get deeper into it right now. For this slide, we will be just looking at these examples first of all. M plus 8 and x plus 45. So variable is this, constant is this, and operation is this. Okay, but first of all, what are these? So variable, coming on to a variable. What is a variable? So the dreaded alphabets entering mathematics. Yeah, variable is a letter or a symbol that represents a number. Okay, like you had one burger. Okay, and you had one burger and there were 3 burgers in the party. Okay, so what is the quantity of burger that others took? Okay, can you tell? Let the unknown quantity be n or x. Okay, and your friends took n or x number of burgers, but you know that you had one, right? And there were actually 3 burgers in the party. Okay, your friend's mom made only 3 burgers. You had one. Your friends had x. So how many burgers your friend had actually? You can find it out by 3 minus x is equal to 1. Because the remaining burgers you had, right? 3 were there originally and x were taken by your friends. So you had only 1, right? So you can find out this from this algebraic expression. Moving on to x this side, 1 to this side, and you will get x is equal to 2. So that's all we do here. In algebra, we find out the unknown quantity and we name the unknown quantity as x or n or any alphabet. Okay, so let's start with it. 4 plus n is equal to 15. We don't know what n is, but we can find it out by using this algebraic expression. Let's move on. What are actually constant and coefficients? What are these? Okay, so actually what are these? Do you know what's a constant? You must have heard it in English, constant, in your storybooks and novels and all these, what are constant? Something that remains fixed, right? Constant is something which is fixed. Okay, it never changes. And co means together, and coefficient means that it is something with the variable. Okay, it is together with something. So constant is something which does not change, it never changes, and coefficient is a number multiplied or divided by a variable, or it is a number which is together with a variable, like the 6x. Okay, let's consider the 6x. 6 is a coefficient. Okay, 6 is a coefficient because it's a partner with x. That's why it's a coefficient. And 5 is a constant because it will never change, right? 5 means 5. Wherever you go, wherever you are, 5 will always remain the same. 5 will always have the same numerical value of 5. That's why it's a constant. Okay, so let's move on. If constant and coefficients are clear to you, let's move on. Okay, so we are here at terms. What is a term? Have you ever heard the word term? Yes, term is actually used to refer to something, right? Like this term is used for a specific word. So these are the terms which we use in algebraic expressions. Terms are individual letters, variables, constants that we are using in an algebraic expression. These make up the algebraic expressions. Okay, so all of algebra contains terms. So what is it? A term is either a single number or a variable, and it can be a combination of numbers and a variable. Okay, so what is it? A term can be a single number, it can be 5, it can be 6, it can be 7, it can be any number. Okay, and it can also be a variable x, m, or it can be n, or any Greek letter, anything. It can be anything, and it can also be coefficients and variables. Okay, so what can it be? 5x, 2n, 3m, it can be anything. So these all consist of terms. So what's there next? They are usually separated by different operators. So the terms are actually separated by operators. Like 5x is a term, 2 is a term, and 3m is a term, right? And when these all are separated by an operator, these all make a what? These all make an algebraic expression. So what's there? Example number 1. Some example of terms are y, 5, 2x, etc. And another example is 6x minus 7 is equal to 2. What are the operators here? Minus and equal. And what are the terms here? 6x, 7, 2. Coefficient is 6. And what is the variable? 7. And what is the constant? Yes, 7 is the constant and 2 is a constant, and both of these are operators. So then the terms in this expression are 6x minus 7 and 2. Okay, let's move on. Now that we have learned what are terms actually, we can differentiate algebraic expressions by on the basis of the number of terms these expressions have. Okay, let's just consider these words first of all. What does mono mean? Does anyone know what does mono mean? You must have heard monotone or monopoly, right? So what does all these words mean? Monotone or monopoly, what does this mean? Mono. Mono means single, okay? Or only one. So that's what mono represents here. So you can just have an idea that monomials have only one term. Okay? And what does a binomial have? Bi, have you ever heard bi? Like bi in bicycle, right? Bicycle means having two tires, right? So a bi means two. So from this two you can have an idea that binomials are the expressions which have two terms in them. So what's next is trinomial. We know tri, what does tri stand for? Tricycle, triangle. In that, what does tri stand for? 3. Yes, tri stands for 3. So we can have an idea that trinomials have got 3 terms in it, right? And what's next? Polynomial. Yeah? Polygon, polygon, polynomy. All these words have got poly in it, right? So what does this poly mean here? More than one, right? So poly means a lot of it, a lot. And poly means more than one, multiple. So you can just have an idea that polynomials are the expressions that have a lot of terms, more than one terms. Okay, so let's go into depth of all these terms. What are monomials? An expression which have only one term. As I said, mono means one, singular. So that's why an expression which has got only one term is called monomial. So what are the examples? All these terms in themselves are examples of monomials, like 10, 3x, 5xy, 2x square. All these have got only one term in it, right? See, it is a single one. Okay, we will consider it as a single term. Even though it has got one constant and two variables, still it's a single term because they are together. They are not separated by an operator. That's why these also come under the category of monomial. Let's go next then. Binomials. What are binomials? The expressions which have two terms are called as binomials. Okay, so binomials, as I said, they have got two terms in it. Like these examples, x plus 10. 1 and 2 terms, right? 3x plus 1. Again 1 and 2 terms. A plus b. 1 and 2 terms. 7x square plus y square. 1 and 2 terms. That's why these are binomials. Okay, let's move on next. What's there? Next we have got a trinomial, and what is it? As I said, tri means having 3 terms in it. Okay, having 3 terms Like here, let's see. 2x is 1, y is second, 10 is the third one. 3y, 3x, let's add another one because it has to be a trinomial, right? It has got to have 3 terms. There are only 2 here. So let's add another one. We can add anything to it. 2n, or we can add 6, or we can add 7. It can be any one of them. Yeah? So we have got 3 terms in total. Now it's a trinomial. Let's move on next. 1 term, 2 term, 3 terms. That's why it's a trinomial. First, second, third. Again, a trinomial. So that's how we can identify all these various types of polynomials, algebraic expressions. Okay, monomial, binomial, trinomial, polynomials. Let's move on to polynomials. What is it? Okay, poly has got a lot of terms in it, more than 1 to be exact. Okay, if it has got 1, then it will come under the category of what? Monomials, right? So anything which has got more than 1 term will come under polynomial. Okay, so 1 or more terms means with non-zero coefficient. Okay, non-zero coefficient means that it should not be 0 x plus 0 y. No, the coefficient cannot be 0. It has to be non-zero. That's why this is the condition for a polynomial. If it was 0, then that means it will come out to be 0 itself. So it's not a polynomial, right? That's why there is a condition that it should have non-zero coefficients. Okay, let's move on next. What's there? A polynomial can have any number of terms. Okay, there is no limit on it. It can have infinite number of terms also. Okay, what are its example? 10 plus a plus b. Okay, we have made it. How many terms are there in it? 1, 2, 3. More than 1, right? That's why it's a polynomial. Or what is another name for this algebraic expression? What is another category that it can come under? Yes, it can come under trinomials. Okay? Exactly. Why? Because it has got 3 terms in it. Let's move on to the next example. 7x plus y plus 5. So it has got how many terms? 1, 2, 3. More than 1 again? Polynomial. And also it can be called trinomial. Yes? Let's move on to next example. W plus x plus y plus z. How many terms it has got? 1, 2, 3 and 4. Right? So how many? What is it? More than 1, right? So that's why it's a polynomial. And there is no other name for it. We can call it polynomial only. Right? So let's go next. Let's test our knowledge. Okay. Classify the following as a monomial, binomial, trinomial or polynomial. So what is it? What is this one? A plus C. Is it a monomial, a binomial, trinomial or a polynomial? Which one is it? For checking that, we will have to check the number of terms in it, right? First and second. It has got 2 terms in it, right? So it will be what? A binomial, right? Yes, it will be a binomial. Let's move on next. Classify the following as a monomial, binomial, trinomial or polynomial. So it will be a what? 5. It has got only one term in it. That's why it will be a monomial. Let's move on next. Classify the following as monomials, binomials, trinomials or polynomials. So AB plus BC plus CD plus DA. Yeah, how many terms has it got? 1, 2, 3, 4. It has got 4 terms in it. That means it's a what? Polynomial. Yeah, it is a polynomial because it has got more than one terms, right? So our answer is correct. Let's move on next. Monomials, binomials, trinomials or polynomials. Which one is it? Let's check the number of terms. 1, 2 and 3. So it's a trinomial. Let's move on next. Yeah, our answer is correct. Okay, so now that we have differentiated algebraic expressions on the basis of their number of terms and also have understood what are actually constants, variables and operators and what are terms, let's move on to the differentiation of terms. Terms are of two types, like and unlike, right? What do you understand by the term like? Like means similar, right? And unlike means which is not similar, which is different. Yeah? Let's move on with this type of differentiation, what it is. Okay. The terms which have same variables are known as the like terms. Same variables means that if a term has got x as their variable, the other term should also have x as their variable. Okay, so that though all these variables, both of these terms will be like terms. Okay, and also 3x and 4x will be like. Okay, the coefficient does not matter here. When we talk about like terms, the coefficient does not matter. The only thing that we have to check is the variable. It should be same. Then only it will be a like term. So for example, we have got 5x and 7x, 2xy and 3yx, 4x square, 7x square, 9x square and x square. All of these are like terms. Why? Because their variables are the same. X square is present in all of these. The coefficients might be different, but that does not matter because we are checking their variables. Now for this example, see, the order is different, but the variables are same, right? X, y and yx are the same. Just like 2 and 3 is the same as 3 and 2, similarly, x into y is equal to y into x. That's why all of these are like terms. 5x and 7x are also like terms because they have got the same variable. Now the terms which do not have the same variables, these are called unlike terms. Now consider these examples: 5x and 7y, 2xy and 3ax, 4x square, 7y square and 9z square are some of the unlike terms. Why are these unlike? Because x and y are not the same. X, y and 3ax are not the same. X square, y square, z square are three different variables, right? Now let's consider this example first. X is present in both of these terms, but the second variable and the first variable of this term are not the same, right? That's why it's an unlike term. like 2 into 3 is not equal to 2 into 4. Similarly, x into y is not equal to x into a. Yeah? That's why these will come under unlike terms. Let's move on to operations in algebraic expressions or operations on terms of an algebraic expression. Addition and subtraction. How do we add and subtract algebraic expression? Now what we have to take care of is we can perform addition and subtraction only on like terms. Okay, terms have got to be like for us to add or subtract them. If they are not like, then we cannot add or subtract them. Let's see this example first. Example number 1. Add 7x plus y plus 7 to 3x plus 2y plus 1. Just like you add this. 3, 1, 2, 1 plus 1, 2, 3, 4, right? We write it in a column form, right? Similarly, we have to write both of these in this form. Okay? The like terms will go below the terms similar to them, and then we add them. Then we add the coefficients. Okay, now how do we do it? Write these two like terms just below each other, constants below each other, and then add them like you do general addition. 7 plus 1 is 8 and y plus 2y is 3y. How come? The coefficient of y is 1, right? 1 into y is y. So the coefficient of y is 1. Now when we add two like terms, we add their coefficient. Okay. What do I mean by that? 2 plus 3 is 5. So the answer will be 5x. Now same with that we did here. 1 plus 2 is 3. So the answer is 3y. Moving on to next. 7 plus 3 is 10. That's why it will be 10x. Okay. Now we have got our answer. The answer is 10x plus 3y plus 8. Let's move on next. Example number 2. Subtract 2x squared plus 5xy plus 1 from 7x squared plus 2xy plus 2y plus 3. So now we have got two different algebraic expressions and we have to subtract this from this. Just like we did in addition, we write the like terms just below each other. Writing the constants at the last like this. 2y has not got any partner, okay, because 2y is present in this expression but it is not present in this expression. That's why we will just leave the space blank here. Okay. And maybe as well write it as plus 0. Okay. That will not make any difference. Now moving on to 2x plus y. 2xy. 2xy we have written here. Now writing its like term just below it. 5xy. 2xy plus 5xy. And 7x square, 2x square. Now we will be subtracting all of it from this, right? Keeping it in a bracket. Let's subtract it all. The signs will change, right? So 7x square minus 2x square is 5x square. 2xy minus 5xy is minus 3xy. Because we are subtracting a bigger number from a smaller number. So it will be negative, right? Now 2y minus 0 is 2y itself and 3 minus 1 is 2. So I hope this one is clear. We have to just keep in mind that the subtraction sign is outside the bracket. Okay. We have to change the signs of all these terms if needed. Okay, we are subtracting it, so we will have to change the signs accordingly. Let's move on to next example to make it more clear. 18 minus 3a minus 11b plus 5ab minus 2ab square plus 5ab square. Okay, minus this term. Minus this expression. Okay, let's first of all change all the signs. The negative sign is outside this bracket. Okay. So the signs will change, right? Minus 10 will become plus 10. And minus 8a will become plus 8a. Minus 7b will become minus 7b. And 5ab square will become minus 5ab square. And 3ab minus 3ab will become plus 3ab. And 4a square b will become minus 4a square. 7b, yeah, it is negative 7b. So we have changed all the signs, right? Do you remember what was the technique to change all the signs? Whenever there is a negative sign outside a bracket, we have to make the signs inside the bracket opposite of theirs. 4a square b was positive, that's why we made it negative, right? And 3ab was negative, so that's why we made it a positive one. 5ab square was positive, so we made it negative. And 8a was negative, so we made it positive. Similarly for 7b and 10. So now let's solve it. 18 plus 10 is 28. Minus 3a plus 8a is 5a. Minus 11b minus 7b is minus 18b. Right? Okay, let's move on. And 5ab plus 3ab is 8ab. And minus 2ab square minus 5ab square is minus 7ab square. And 5a square b minus 4a square b is what? A square b. Okay, because 5 minus 4 is 1. So the coefficient of this term will be 1. But 1 into anything is the number itself, right? And in this case, 1 into this term will be the term itself. So it will be a square b or 1a square b. Both are the same thing. So this example is clear, right? Let's move on. Multiplication of algebraic expressions. Now how do we multiply these algebraic expressions? Unlike addition and subtraction, in multiplication and division, we can try it for unlike terms also. Okay, now what do we do with like terms first of all? The coefficients will get multiplied. If it is x into y, then it will be xy. Okay, there is no need for them to be like. We can multiply unlike terms also. Okay, so the coefficients will get multiplied and the power of the resultant variable will be the addition of the individual powers. Okay. So what are they saying for like terms actually? Suppose we have got like terms 3x into 4x. Now what do we do? How do we multiply it? According to our first step, we will multiply the coefficients. The coefficients are 3 and 4. So let's multiply them. 12. 3 into 4 is 12. Now we will have to add the individual powers. Now what are powers? Power of x here is 1 and power of x here is 1. So what is the addition of their individual powers? 2, right? 1 plus 1 is 2. How come its power is 1. How do I know its power is 1? Actually, any number's power 1 or any variable's power 1 is the variable itself. Okay, so I can write this variable as x to the power 1, right? So what do I get? 3 into 4 is 12. And according to our second step, the power of the resultant variable will be the addition of the individual powers, okay, which is 2. So is this one clear? Let's just move on with it and see some more examples. What are these? Product of 2x and 3x will be 6x square. How come? We have to first of all multiply the coefficients, which will give us 6. And then we will have to add their individual powers. X to the power 1, x to the power 1, x to the power 2, which will be the addition of the individual powers, which will make it 2. So our answer, that's how we get the answer 6x square. Let's move on to the second example. Product of 2x, 3x and 4x. How do we multiply these three terms? First of all, let's multiply their coefficients. 2 into 3 is 6 and 6 into 4 is 24. That's how we get 24. What's the next step? We add the individual powers. X to the power 1, x to the power 1, x to the power 1. If I add all of their powers, what do I get? 3, right? So that's why it's 24x cubed. Now, that's how I got my answer. Let's move on next. Take note of the following points for unlike terms. Now, how do we multiply unlike terms? See, the first step is the coefficients will get multiplied. What do they mean by it? X into y is xy. That's how the coefficients get multiplied. The coefficients of 1 was 1. Coefficient of y was 1. Of x was 1. That's why the coefficient, when I multiply it, 1, I get 1 itself. Another example that I can take for it is suppose it is 3x into 4y. Now how do I do it? With my first step, I multiply the coefficient, right? 3 into 4 is 12. Now my second step says that if all the variables are different, then there will be no change in the power of the variables. See, in this example, all the variables are different, right? X and y are different. So there will be no change in the power of the variables. I do not have to add the powers, right? So I can just write them as it is, x, y. And if some of the variables are same, then the respective power of the variables will be added. What do they mean by it is, let's see this example. This example number 3. 2x square, 3x and 4y. Now what do I see here? X square, y. Now for x square and x, the variable is the same, right? X. Only the power is different. The power here is 2 and the power here is 1. So the power is different, but the variable in itself is the same, right? So according to my third step, the respective power of the variables will be added, right? If the variables are same, then the respective power of the variables will be added. Now let's do this example number 3. According to my first step, let's first of all multiply these coefficients. Okay, 2 into 3 is 6 and 6 into 4 is 24. So 24 is here. Now next step was, if the variables are different, then there will be no change in the power of the variables. Okay, y and x are different. So let's write x and y. But for x, the variables are the same, right? But the power are different. So let's add their powers. 2 plus 1 is 3. So x will be x to the power 3y. Okay, just like this answer. 24x cubed y. We pronounce x to the power 3 as x cube and x to the power 2 as x square. Okay. Now let's see example 1 and example 2. Product of 2x and 3y. According to my first step, let's just multiply their coefficients, which will be 6. Now second step says if the variables are different, write them as it is without adding their powers, x and y. Example number 2, 2x, 3y and 4z. 2 into 3 is 6, 6 into 4 is 24. So I can write it as 24. Now x, y and z are here. The three of the variables are all different. So I can write them as it is, right? Without adding their powers. Without doing anything to their powers, I can just write them as it is. X, y, z. So this is my answer. Let's move on to next one. Multiplying a monomial by a monomial. Okay, we will be multiplying a monomial with another monomial, which is pretty easy like we were doing in the earlier examples. It's just like that. Okay, multiplication of terms 4 and y will be 4y. Okay, first of all 4 and y both are monomials, right? So if I multiply both of them together, I get 4y. Okay. 4 into y is 4y. Now if I multiply 4x and 3y, let's follow these steps. The coefficients will get multiplied and give us 12. And the variables are all different, so this will give us xy. Let's move on next. Multiplication of terms 4x and x. Okay, this is the multiplication of like terms, right? Let's just multiply their coefficient first. X is actually what? 1x, right? So 4 into 1 is 4 and adding their powers. Adding the powers of the like variables, which will give us 1 plus 1 is equal to 2. So it will be 4x square. So we have done this one. Let's do multiplying a monomial by a polynomial. Now this one can be a little bit tricky, but it's easy. How do I say that? 4 and x plus y. How do I multiply that? It is actually nothing but 4 into x plus y, right? Now for solving this bracket, I will have to multiply this to all the individual terms inside the bracket, right? So 4 into x plus 4 into y, which is what? Multiplication of monomial with another monomial, right? So 4 into x will be, as we did earlier in the examples, 4x, and 4 into y will be 4y. So 4x plus 4y is this, 4x plus 4y. This is our answer. Yes, like we have got here. Isn't this easy? Let's move on to example number 2 then. 5x and 3y plus 2 is nothing but 5x into 3y plus 2. And we will have to multiply it with the individual terms inside the bracket. 5x into 3y plus 5x into 2. Yes? Now, this will become the multiplication of monomial by a monomial, right? So, let's do for these two first. 5 into 3 is 15, multiplying the coefficients. And multiplication of two different variables, x, y. Plus, multiplying these coefficients. 5 into 2 is, yes, 10. And x into 1 is x. So 10x will be our answer. Let's move on to the next example. Multiplication of 4 and x plus y plus z. What is it? 4 into x plus 4 into y plus 4 into z. Yeah, which is what? Monomial into monomial. 4 into x is 4x, 4 into y is 4y, 4 into z is 4z. Right? Let's move on to next. This one was easy. Multiplication of 2x into 2x plus y plus z, which is nothing but 2x into 2x plus 2x into y plus 2x into z, which will be what? Let's first of all multiply these. Multiplying the coefficients, we get 4, and adding the individual powers of the like variables will give us x square. Now multiplying the coefficients again, 2 into 1 is 2 and x into y is xy. For the third one, multiplying the coefficients again, 2 into 1 is 2 and x into z is xz. This is our answer, as we can see here. So this one is clear, right? This one was easy. If we know how to solve these brackets, we can just employ these steps of multiplying a monomial by a monomial in this one. Whenever we are multiplying a monomial by a polynomial, we just have to open up the bracket, multiply the monomial with each of the individual terms in the polynomial. Saying that, let's move on further, multiplying a polynomial by a polynomial. Okay, how do we multiply both of these? It's just the same as the earlier one, monomial by a polynomial, but the brackets get complicated here. Okay, this is the same as 4x into x plus y plus y into x plus y, right? How come? We will be multiplying this with the bracket first and then plus this with the bracket next. Okay, 4x into this bracket plus y into this bracket. So this is what I have got here. Let's solve this like we did with the monomial into a polynomial. 4x into x plus y will be 4x into x plus 4x into y. Yes, so we have solved this one. Let's move on to this one. Plus y into x plus y into y. Right? Okay, let's move on next. Solve this further. 4 into 1 will be 4. And adding the individual powers, we will get x square. Right? Plus 4x into y, multiplying the coefficients, which will give us 4, and x into y is xy, multiplying two different variables. Now yx is yx as it is, and y into y will be, multiplying the coefficients will give us 1, and y into y means adding their individual powers 1 plus 1, which is 2. So y raised to the power 2. This is our answer. How come 5xy is here? They have added all the like terms. Okay. How do we add them? 4x square, 4xy plus yx, or 4xy plus xy. 4 plus the coefficient of this one is 5 xy plus y square. So the basic thing for this is you have to identify all the like terms for it. That's how you get it. And then add all the like terms like you do it. Add the coefficients and write the variables as it is. Let's move on with the second example. 5x squared plus 3y into 3y plus 2. Again, multiply this with this bracket and then multiply this with this bracket. 5x squared into 3y plus 2 and plus 3y into 3y plus 2. See, I haven't used the multiply sign here. Why? Because writing a bracket just beside it makes it a multiplication operation. Okay. So let's solve it again. Multiplying this with the individual terms inside the bracket, I get 5 into 3 is 15. And x square into y is x square y. Because both of these are two different variables. Now 5 into 2 is 10. And x square into 1 is x square. Let's solve this one. 3 into 3y. 3 into 3 is 9. And y into y is, adding the individual parts 1 and 1, 2. Y to the power 2. Now multiplying this with this. 2 into 3 is 6 and y into 1 is y. So 6y. Now this is my final answer. Yes. So let's just erase it and move on to the next example. Okay. Multiplication of 4x plus 2 and x plus y plus z. How we do it? Multiplying this with this bracket and multiplying this with this bracket, which will give us 4x into x plus y plus z plus 2 into x plus y plus z. Yes, now we have to multiply them individually. Once with this, then with this, and then with this, and then 2 with z. And then when we will add the like terms, if there are any, we will get this answer. Similarly with example 4, all of these are the same. Just employ the same method like we did for all these example 1, example 2, example 3 and you will get the answer for example 4. Try and find it out. Let's move on to the next slide then. Identity. What is an identity? Have you ever heard the word identity? Identity card, ID card, you must have heard there. What is identity? It is your name. It is your identity, right? That's what it means. It is what you are. So it is a relation which satisfies A is equal to B. Okay, that is their identity. What is the identity of an algebraic expression? That expression itself, right? So if there is an expression A and there is an expression B and both of these are equal to each other, that means that they are necessarily the same algebraic expressions. Okay, they might look different but they are basically the same. Okay, it is a relation which satisfies A is equal to B, where A and B will contain some variables and for any values of these variables, the relation A is equal to B will always be true. Like if there are two algebraic expressions A and B and I take the value of the variables as 2. If I put the value of variable as 2, in both of these expression and I get the same answer, then this will prove that this is the identity of these algebraic expressions. Now let's consider this example. Consider x plus 1 into x plus 3 is equal to x square plus 4x plus 3. So what is there? Let us take x is equal to 2 and LHS is equal to 2 plus 1, 2 plus 3. Okay, in this algebraic expression, I have taken x as 2 everywhere. Okay, wherever there is x, I have written 2 instead of this x. In place of this x also, I have written 2. So let's first of all consider this left hand side equation. Okay, it is on your left hand, right? It is on the left side of this equal to sign. That's why we call this LHS, left hand side. So x plus 1 into x plus 3 is the LHS. It is the left hand side. If I keep 2 at the place of this x everywhere, what do I get? 2 plus 1, 2 plus 3. 2 plus 1 is 3. 2 plus 3 is 5. So 3 into 5 is 15. Now let's consider our RHS, or the right side of the equal sign, which is x square plus 4x plus 3. Keeping 2 in the place of x everywhere, what do I get? 2 square plus 4 into 2 plus 3, right? Now 2 square means 2 into 2, okay? 2 to the power anything means I have multiplied 2 with itself that many times, okay, whatever the power is. If the power is 2, I have multiplied 2 with itself twice. If the power is 3, I have multiplied 2 with itself thrice. That's how the powers work, okay? So now 2 to the power 2 means 2 into 2, and 4 into 2 is 8 plus 3. Now 2 into 2 is 4, 4 into 2 is 8, 3 is 3 itself. 4 plus 8 plus 3 is 15. What does it say? That this expression is equal to this expression, right? If I keep any value of x, if I keep it as 3, if I keep it as 5, if I keep it as 1000 or any number, I will always get this side is equal to this side. This is my identity. Okay, similarly for any values of x, the relation will always be true. Always be true, because LHS will always be equal to RHS, or left hand side of the equality sign will always be equal to right hand side of the equality sign. So let's consider these standard identities. Okay, standard identities. These are the identities that are used all throughout mathematics when you go in higher standards. These identities are used everywhere. Now what are these? A plus b square a plus b whole square is equal to a square plus 2ab plus b square. Okay. A plus b raised to the power 2 will be equal to a square plus 2ab plus b square. If I keep the value of a as 1 and b as 2, and same here, if I keep the value of a as 1 and value of b as 2, I will always get LHS equal to RHS. Okay, so these are the identities that we used all throughout mathematics. And what does this a plus b to the power 2 mean? A plus b to the power 2 means a plus b into a plus b. Okay, like we did 2 to the power 2 means 2 into 2. So a plus b to the power 2 means a plus b into a plus b. Okay, multiplying it twice with itself. So what do we get when I simplify these variables? Just employing our method of multiplying polynomial with polynomials. Yeah, do you remember how we did it? Multiplying this first term with this bracket, second term with this bracket, I will get this equation when I solve it. Okay, so these are some of the standard identities. Similarly, for a minus b to the power 2 is just like this. A minus b into a minus b itself. And we will get this one in the RHS. Similarly, for a plus b into a minus b, we will get a square minus b square. So these are some of the identities that we have to use. And you can remember it, or you can either solve it by yourself. Like we did a plus b into a plus b. If you multiply these variables together, add the like terms together, you will get this right hand side. Let's do some examples for it. How do these identities make our work easier? For example, finding the square of 102 will require us to multiply 102 with itself, which can get quite lengthy, right? So to make it easier, I can just write it as 100 plus 2 to the power 2, right? Which will be keeping 100 as a and 2 as b. This will be the same as a plus b to the power 2, right? The first identity. I can write this as a square plus 2ab plus b square. Can't I? E square plus 2ab plus b square, like this. Now let's simplify it. A was 100, so 100 to the power 2, and 2 into a, which is 100, and into b, which is 2, plus b to the power 2 means 2 to the power 2. Now 100 to the power 2 is, you know, when you multiply the multiples of 10 with themselves, you just increase the number of zeros. So if I multiply 100 with 100, I get 10,000. So now 2 into 100 is 200, and 100 into 200 into 2 is 400, right? Writing it as 400 plus 2 into 2 is 4. Simplifying it, I get 10404. So didn't it become easier now? Instead of multiplying it, it would have become lengthy. But we just disintegrated this into smaller and numbers which have easier calculations. 100 has easier calculations, right? Instead of 102, we can write this as 100 plus 2. And we have got this in the form of a plus b to the power 2. A square plus 2ab plus b square. So let's go on next to the example number 2. Prove that 3a plus 7 to the power 2 minus 84a is equal to 3a minus 7 to the power 2. So for solving this question, I will have to use this first identity, a plus b to the power 2. Okay. Now let's keep 3a as a, 7 as b. This will make it as 3a, a square plus 2ab. 2ab means 2a is 3a and b is 7. Plus b square, 7 square. Minus, this is this term, right? Now minus 84a. This is my question. 84a. I am solving the LHS part first. Instead of this, I have written this in the form of this identity. and written 84a as it is here. Okay, I have changed nothing but written this as this form. Okay, so now what will it become? 9a square plus 42a plus 49 minus 84a. If I solve this, I will get this. And write this 84a as it is, which will give me 9a square minus 42a plus 49. Okay. Now my RHS is this, right? 3a minus 7 square. I can write this in the form of this identity. So let's do it. Keep 3a as a and 7 as b. A minus b whole square. I can write this as a square minus 2ab plus b square. So that's what we have done here. Which when I solve this, I get this. Okay, as my final answer. And as you can see, this is equal to this. Our LHS. Both of these are equal. LHS is equal to RHS. That's why it is proved that this side of the equation is equal to this side of the equation. Okay. So yes, this is all for algebraic expressions. So today we covered everything there was in basics of algebra. What did we learn? Constants and variables, and we learned terms, and then we learned monomial, binomial, trinomial, and polynomial, right? And then we did like and unlike terms. And then we did subtraction and addition. And then we did multiplication of monomial with a polynomial, monomial with a monomial with a monomial, and then with a polynomial, and then polynomial with a polynomial, right? And then we did some identities. And then some standard identities. And that was all. So yes, what can you understand from all these? That an algebraic expression consists of these constants and variables, and these together make up terms. There are coefficients also. So these three make up terms which can decide if the algebraic expressions are monomial, binomial, trinomial or polynomial, depending on the number of terms, right? Second comes, these terms can be like or unlike depending on the variables. If the variables are same, then these terms are like. If the variables are not same, these terms are unlike. Next, what we did, addition and subtraction, which is possible only for like terms. We cannot perform addition and subtraction on unlike terms. Next comes multiplication, which is possible on like and unlike both. And only thing we have to take care of is, in case of like terms, we add the individual powers, and in case of unlike terms, we multiply the variables together, we write them as it is. And if the variables are same, we add the individual powers and multiply the coefficients together. In the case of identities, what we do is, A is equal to B, we solve the LHS, then we solve the RHS, and if both of these are equal, then it is an identity. And the standard identities include A plus B to the power 2, A minus B raised to the power 2, and A plus B into A minus B. So these are some of the standard identities which are used in mathematics and which can be used to make our solution easier and simplified. Okay, so this is all there is to algebraic expression. Thank you for being with us till the end of the video. See you next time. Have a good day.